Hello students. In the last lecture we have studied about the different terms used in case of a laser. That one is absorption of light, spontaneous emission and stimulated emission. In case of absorption of light, when we absorb the incident light and electron, atom, ion or molecule will shift from their ground level to excited level. And in case of a spontaneous emission, these excited level if come back to the ground level without any external agency or force, that one process is known as spontaneous process. And in case of a stimulated emission, when the excited atom, ion or molecule will come back to the ground state by the external agency of energy, that one is h nu. That one process is known as stimulated emission. In today lecture we will discuss about the laser idea. We will use the basic concept studied in previous one lecture. By the use of these terms, we have clarified that the when the electron, atom or ion will come from the excited level to the ground level, it will emit the energy in the format of h into nu. Now since the energy difference is finite, so the energy levels having the definite, or the we can say particular finite values, but in real energy levels are not infinitely sharp. Let us suppose the frequency spectrum of emitted or the absorbed radiation is described by a shape line shape function g nu, and g nu into du nu is the probability of emission or absorption of a photon with frequency range of nu and nu plus d nu. So by applying the normalization condition from 0 to infinite, g nu into du nu is equal to 1. We know that from the stimulated emission, or we can say from the previous one lecture, in case stimulated emission, excited state atom will come back to the ground state atom with the external energy of h nu. Let us suppose n is the concentration at the excited level, and m is the concentration on the ground state. Then in case of a stimulated emission, dn upon dt means rate of change of concentration from higher to lower level is equal to negative of nm bnm nu n rho n and g nu, where n negative sign is showing that the concentration in case of a stimulated emission concentration is decreasing with the passage of time. bnm is the Einstein coefficient for stimulated emission, as it is clear from its symbol n to m means excited level to ground level. And rho nu and g nu are we have already defined. And in case of a absorption of a light, dnm upon dt is equal to nm dn mn. यहाँ पे हम टर्म एम एन यूज़ कर रहे हैं और यहाँ पे एन एम यूज़ कर रहे हैं, क्योंकि यहाँ पे हम एम ग्राउंड लेवल से एक्साइटेड लेवल के अंदर जा रहे हैं. तो इट वन इज़ पॉजिटिव बिकॉज द कंसंट्रेशन एट द हायर लेवल इज इंक्रीज्ड. नाउ द एनर्जी डेंसिटी रो न्यू is equal to I nu upon C. Energy density, where I nu is the intensity of the wave, is defined by the unit watt per unit area per unit frequency interval. Now let us consider the beam of intensity I nu is passed through a medium of a thickness Iz. Let us suppose a beam of I nu frequency is passed through a medium of thickness, this one thickness डेल्टा जेड. ये आई न्यू फ्रीक्वेंसी इस डेल्टा जेड थिकनेस के थ्रू जब आप पास आउट करोगे ऑफ एरिया ऑफ क्रॉस सेक्शन इज ए. देन द अमाउंट ऑफ एनर्जी released per unit time is equal to absorption energy from M to N minus emission energy from N to M. Means in case of absorption, electron atom ion will shift from lower level to higher level, and in case of emission from higher level to lower level, multiply by the h nu. Now the amount of energy per unit time is equal to I nu z plus dz. Let us suppose this one direction is z direction, minus I nu into z multiplied by area of cross section is equal to N Bn to M, N to M minus this one multiply by this. If we take its difference is equal to d I nu, and dz from this one taking in left hand side, and area is in the right hand side, we will get the equation by simple adjustment. Now we know that for a degenerative energy levels, Gm into Bnm is equal to Gn into Bnm. This one is the last result of the previous one lecture, and An means equation number 6th and 7th we have already derived in last one lecture. Using these two equation, or we can say using equation number 6th in equation number 5th, we will get equation number 8. This one is the simple calculation by which we are just substituting the value of B Nm from equation number 6th in equation number 5th. We will get